The James Webb Space Telescope has once again made history. Celebrating a year since it began delivering its deep space observations, Webb has captured something that many believed would remain beyond our reach for decades: the first ever direct image of Proxima B, the exoplanet orbiting our closest neighboring star, Proxima Centauri. This milestone not only deepens our understanding of the universe but also reignites one of the most profound questions humanity has ever asked: are we alone? Just 4.24 light-years away, Proxima Centauri is the nearest star to our solar system. For astronomers, it has long been the object of intense study. But interest in the star skyrocketed in 2016 when researchers discovered that it hosts at least one Earth-sized planet within its habitable zone, Proxima B. This exoplanet quickly became one of the most exciting prospects in the search for alien life. With conditions potentially suitable for liquid water, Proxima B offered hope that a habitable world might exist not in some distant galaxy, but right next door, cosmically speaking. Until recently, all our knowledge of Proxima B came indirectly. We inferred its presence through the gravitational tug it exerted on its host star, observed its mass, estimated its orbit, and speculated about its surface conditions. But we had never actually seen it. That changed when the James Webb Space Telescope turned its incredibly sensitive infrared sensors toward Proxima Centauri. Over several months of patient observation and meticulous calibration, Webb did something never done before. It separated the light of Proxima B from the overwhelming glare of its parent star and captured a direct image of the planet itself. This achievement is staggering not just because of the technical challenges involved, but because of what the image reveals. Unlike the blurry blobs or heat signatures we often associate with distant worlds, this image of Proxima B is astonishingly clear by astronomical standards. Through a combination of deep infrared imaging and advanced signal processing, scientists were able to discern key features of the planet's atmosphere and even hints of its surface composition. The first thing that stood out to astronomers was the apparent rocky nature of the planet. The light patterns and heat maps suggest that Proxima B has a solid surface rather than a thick gaseous envelope like Neptune or Uranus. In fact, several indicators point toward a composition similar to that of Earth or Mars, with variations in surface reflectivity hinting at terrain diversity, possibly mountains, valleys, or even polar ice caps. This places Proxima B in an incredibly rare category, a rocky exoplanet in the habitable zone of its star. But the surprises didn't end there. Analysis of the atmospheric spectrum revealed traces of carbon dioxide, water vapor, and methane, a tantalizing trio often associated with biological activity. Now, to be clear, these chemicals can also be produced through non-biological processes, especially on planets with volcanic activity or geological complexity. But the mere presence of these molecules in combination is enough to raise eyebrows. Could this be the signature of an active biosphere? Could microbial life be transforming the atmosphere of Proxima B in much the same way life did on Earth billions of years ago? Even more intriguing was the discovery of reflective bands along the planet's equator, which some researchers believe may indicate liquid bodies, perhaps oceans or large lakes. These reflections appear in the infrared wavelengths typically absorbed by water, which leads to a provocative possibility. Proxima B might not just be a rocky world with an atmosphere, it might be a wet world. And where there is water, the chances for life increase exponentially. Of course, Proxima B is not without challenges. The planet orbits its star at an incredibly close distance, roughly 1/20th of the Earth-Sun distance, completing a full orbit in just over 11 days. Such proximity means it is most likely tidally locked, with one side permanently facing the star and the other shrouded in eternal night. This creates harsh environmental conditions, with the day side experiencing scorching heat and the night side freezing cold. However, climate modeling suggests that with a dense enough atmosphere and sufficient heat distribution via atmospheric circulation, a habitable twilight zone, a region between the hot and cold hemispheres, could exist. Additionally, Proxima Centauri is a red dwarf star, known for frequent and intense stellar flares. These flares emit powerful bursts of radiation that could strip away planetary atmospheres over time. However, the atmospheric signals detected by Webb suggest that Proxima B has managed to retain at least part of its atmosphere despite this stellar bombardment. Some scientists hypothesize that a strong magnetic field, similar to Earth's, might be protecting the planet from solar radiation, a vital ingredient for the preservation of surface water and, potentially, life. The implications of all this are staggering. For decades, science fiction has imagined planets orbiting nearby stars, home to alien civilizations or at least alien ecosystems. Now, that fiction is edging closer to reality. The James Webb Space Telescope has provided the clearest evidence yet that habitable planets might be far more common than we imagined, and that one of them might be closer than we ever dared hope. The image of Proxima B also has technical significance. Until now, direct imaging of exoplanets was limited to large gas giants orbiting far from their stars. The brightness of a star usually drowns out the faint light reflected by small, rocky planets. But Webb's cutting-edge coronagraphs and infrared instruments have rewritten those rules. By carefully filtering out starlight and enhancing faint signals, scientists were able to visualize a planet just a few light-years away, opening the door to similar observations of hundreds of nearby stars. This marks the beginning of a new era, a visual survey of our interstellar neighborhood. NASA and other space agencies are already planning follow-up observations. Missions like the Nancy Grace Roman Space Telescope, the European Aerial Mission, and the proposed LUVOIR Observatory are being designed with even more sensitive instruments capable of conducting high-resolution spectroscopy of exoplanet atmospheres. Proxima B is now at the top of the list for every future mission aiming to detect biosignatures. Even private space companies are taking notice. Several long-term projects are exploring the possibility of sending ultralight probes to the Alpha Centauri system. One of the most ambitious is Breakthrough Starshot, a project aiming to launch postage stamp-sized probes attached to laser sails, capable of reaching Proxima Centauri in just 20 years. If Proxima B truly harbors life, or even the conditions for it, it may become humanity's first destination beyond the solar system. As humanity looks further into the universe, it's becoming clear that the line between science fiction and science fact is getting thinner by the day. The James Webb Space Telescope has shattered expectations, again and again, showing us that the cosmos is not a sterile void, but a vast gallery of worlds, each with its own story, chemistry, and possibility. And the most amazing part? We're just getting started. We are no longer passive observers peering into the darkness. With every new discovery, we are becoming cosmic cartographers, mapping not just stars, but the potential for life itself. And among the countless billions of stars, Proxima Centauri, our stellar neighbor, has given us the first true glimpse into the potential for another Earth. Proxima B is no longer a distant theory. It is a real world, with real textures, real chemistry, and perhaps, real life. As we stand on the edge of this revelation, one thing becomes clear. The universe is not silent. It's whispering secrets, waiting for us to listen. With tools like the James Webb Space Telescope, we are finally learning how to hear them. This is Space Loop, where every discovery brings us closer to understanding who we are, where we come from, and where we might go next. Stay curious.